Here we have our third presentation for Docker in production today. Today we have Eric Drobizeski, okay. He's senior architect for Liberty Mutual, and Michael Letourneau, who is an architect for Liberty Mutual as well.
That was very good.
They'll be presenting, that's my high school French there for you. Presenting on all roads lead to the cloud and Liberty Mutual's journey. So give them a big welcome. Big Docker Column welcome for both of them.
Thank you.
Thanks.
Good. Can you guys hear us okay? Okay.
Cool.
So Eric Drobizeski, Senior Architect, Liberty Mutual. I'm here with Michael as we talked about to talk about our journey to the cloud with Docker. Just a little background on Liberty Mutual to start. We're a global diversified insurer, third largest insurer of property and casualty insurance in the United States. We employ over 50,000 people across the world. One of our goals at Liberty Mutual Insurance is to help people preserve and protect what they earn, build, own, and cherish. Keeping this promise means we are there when our customers need us most. Throughout our operations around the world, we're committed to providing insurance products and services to meet the needs of individuals, families, and businesses, offering diverse and dynamic work environment for our employees and supporting our communities. When we look at our company as an organization today, we've got a set of principles that we're kind of anchored on in terms of some of our transformation, really looking at our digital transformation as a business and also our technology transformation that we've been undergoing for the past few years. Our teams are anchored on these principles, and at the core of it is really our people, investing in them, looking at how we can work differently, becoming a more product-centric organization, and building a sustainable, agile culture that allows us to deliver our customers an exceptional experience. We look at public cloud as really a strategic enabler for this. It's not just another data center, but for new and emerging capabilities we can quickly tap into and accelerate our business. Our teams, they're focused on driving all that they do through code today. Software-defined processes are rewriting how we've traditionally handled infrastructure and operations. To shift their focus now, we're looking more at how they can work on more differentiating activities and really growing Liberty Mutual in many new ways. Continuous deployment for us has been something we've embraced for several years now, and that's critical to our success so that teams can deliver business value out across all of our technology platforms across the globe safely and securely. And the other piece of this, when we look at it, is critically important, is balancing our investments. As we invest in new and innovative technologies, we have to also look at this to reduce our technical debt and drive down our overall expense ratios. So these are all the important factors that we look at and kind of balance as we go on this journey of our digital transformation. And kind of as we move forward, this really touches more on how Docker's been a part of this. So when we looked at this back a few years ago when we kind of started this journey, we had a good example in place in terms of some of our experiences with technology like Cloud Foundry. And what that provided was an amazing way to quickly and simply get applications out to the cloud on a platform as a service. It fit well for great microservice-based applications, greenfield applications, and these net new development efforts that we had. But it didn't always fit the mold quite as well in terms of some of the things that we needed to do for more traditional applications. As you can imagine, in a 106-year-old insurance company, there's a lot of technical debt that we've got to kind of resolve to move workloads to the cloud effectively. So what we really sought out to do was create a traffic system of sorts, kind of a multi-lane highway, where you could accelerate application delivery into the cloud in a way that gave us better portability, better speed, better agility for our developer teams, and better cost in terms of density out there for these workloads. So what we really embraced was a model that we could containerize some of these traditional legacy applications, and as I said, get them to the cloud more effectively. Modernize some of these into microservices if it makes sense, and inspect them for that opportunity as we kind of went along this journey. Some of those things we're looking at is our kind of traditional service-oriented architecture and how that may decompose and become more microservice-based. And then also using Docker to help fuel innovation around net new microservice builds for some of our digitally native efforts across Liberty Mutual. So what we've really built here now is the means that we can move workloads more effectively into cloud platforms using Docker Enterprise Edition to do that. And what we found at Liberty Mutual by pairing Docker and Cloud Foundry together, we have great abstraction for our developers now to be innovative in many new ways and also be cost effective from an operations perspective. When we step back and kind of look at how some of this started, really back in late 2015, we were looking at container technology in pretty early days. And what we sought out to do was start to look at, well, how do you start to build out an ecosystem around this? Docker was fairly early then. Technology like Kubernetes was just really being on the cusp of being a thing even. And what we saw was that there was a lot of complexity to it, but we also saw there was a lot of potential and a lot of value. So when we got started with this, we kind of, several of us, Michael included, we kind of started to tinker with Kubernetes and started to get some experience with that. And what we quickly learned is that although valuable, it was at the time back then very immature, very complex, and also not extremely stable. So with the proposition of bringing better value and better speed to our development teams to drive our business forward, we kind of took a step back, and at the time in 2016, Docker kind of evolved. Some of their later releases came out with Docker Swarm, and eventually Docker Data Center, or as we call it today, Docker Enterprise Edition. And what we found there was a lot of simplicity to get better value out of this that allowed our teams to focus on driving this more effectively and not some of the engineering efforts that we would have had to encounter with Kubernetes originally. So Docker Enterprise Edition today at Liberty Mutual is really the core platform offering we have for running containerized workloads across multiple lines of business, whether that's commercial lines, personal lines, or our global specialty lines of business. And we're using that, again, to really move to the cloud in a more effective model. And as we go forward, we certainly have some eyes on kind of pivoting more back towards Kubernetes to address some scale issues that we'll talk about as we kind of go through here. But for today, what we're seeing with Docker Swarm and Docker Compose, it's got us to a pretty significant state of maturity over the last 2 years. And, I'm going to hand off here to Michael to really talk about the use case specifically to our U.S. consumer markets line of business.
Hi, afternoon. So I work with the U.S. consumer markets section of the company. Big company, different business units. U.S. consumer markets does auto, home, motorcycle, rental. If you see the commercials that say Liberty stands with you, essentially that section of the company is the company I work with on the IT side. Our start in going down the road of containers and the cloud really started, as Eric mentioned, about 2016. We looked at the Kubernetes and it was okay. It just was really complex. It didn't seem to give us the value that we were looking for as a company, and being able to invest in software that was easy to use and would actually enable developers to jump on things quickly. And then Docker Swarm came out with their Swarm version. And that was something that we were really interested in. At the same time, we got a request from our CIO saying, we need to look at this cloud and we need to look at getting into the cloud. And we want to pick an application and we're going to put it out into the cloud. We don't want to just lift it and reinstall it out there. There's not value in that. We want to get some of the advantages of going to the cloud. We want to be able to be fast. We want to be able to deploy it quickly. We want to be able to roll it back quickly. Things that really inside our company and our own data center, we just can't really do right now. So the first application that was picked was our sales compensation application. This application actually deals with the commissions that all of our outside sellers receive for payment for selling our insurance. So it's a really important system because anybody who is selling our business wants to know how much money they're making. And if they don't see it, they don't sell it, and that affects our paychecks. So really important. This was an old system. It was using a Java batch on IBM WebSphere. It had a web UI that was actually based on a hardware machine, so to speak. And it was using Oracle database. So it had some caveats that were going to make it difficult. Oh, and the application team, of course, did not want to have to do much work to get it out there. They wanted to say, It's your job, get it out there. So not really a DevOps mentality, more of a, here, you guys take it and do it. And that was the initial application that we were told, okay, get this to the cloud. About 2 months after that was given to us, another team was formed inside of our specific group to actually go out and take a look at, okay, so rather than just move things to the cloud, let's look at how we can architect things using microservices and come up with a next generation architecture that anybody that is in our area could actually pick up and use themselves without having to go back and refigure everything else out. So these were totally separate requirements. You had essentially not quite lift and shift, and then you had hey, let's support a brand new architecture that doesn't exist yet and we're still thinking of. So we had changing requirements, totally different services between the two. On the next generation architecture, what they actually decided to go with initially was the Netflix OSS model. So Eureka, Zool, those type of services. And they wanted to be able to support things like Node.js and Spring Boot within their templates, so that essentially people could pick what they wanted to for a language and push it out there. Other requirements that kind of went hand in hand with those first two applications, so to speak, were that, okay, you can't just deliver dev. People want to be able to go all the way to production. If you give somebody a development environment and they can't get to production, what use is it? So you have to be able to provide something that's going dev to prod. Automation. You've got to do automation wherever you can. We need to be able to replicate that. That's been the biggest problem with IT in-house previously, was that, yeah, everybody's got scripts, but that's not the same as automation. CI/CD, as Eric mentioned, it's important. We had a huge amount of internal testers that manually tested applications. That's not good going forward. You need automated testing. You need CI/CD. Security threw in their point and said, encryption. Everything encrypted, whether it's at rest or in flight, it has to be encrypted. There can be no clear text anyplace. And the final requirement, which was in some arguments the most important, was you need to give the developers a playground and not put them in a box. They need to be able to go out there and do stuff that they want to and figure it out and get out there. Not have to wait and say, okay, this is the path I can go to and it's the only path that's available to me. So those, as well as those two application requirements, were essentially where we started off with. So our first round out there, we had already picked AWS. We had some teams playing around in AWS, so we knew we'd be going to AWS for our deployment. We'd already decided that Kubernetes was off the table at the time because it just was not something that we wanted to roll out and try and support with our teams out there. Docker Swarm had come around. Docker Data Center 1.0 was out there, and it seemed to be something that we really wanted to look at. It was from Docker, so hey, the parent of containers was actually putting this out there. Good thing. We already had Jenkins in-house, so we knew we were going to be using that for our CI/CD process, whether that was the pipeline for creating the environment that the containers ran on, as well as the pipeline for building the containers. So our first brush out here, we went with the Docker Data Center 1.0. At that time, I don't know if anybody else out here has used Interlock way back when it was like open source and out there for free. We used that. We had an ALB sitting in front of things, and we used Nginx to kind of integrate with the Interlock service. Interlock essentially injected some information inside Nginx to route to your containers. Some very, very basic service discovery method. And we used Jenkins to essentially deploy this. And when I say deploy this, the infrastructure was very rudimentary and basic. We had taken the quick start and we had chopped it up to actually work in our environment. The basic one available from AWS was great if you had a clean slate. Being a big enterprise, we had our requirements already dictated and a VPC already created for us that we needed to fit into. So we had to slice that up and get things working, and it was a little difficult.
Yeah, just one other point of emphasis on that, Michael, and a question that often comes up to us at Liberty Mutual is like, well, you guys are already in AWS. Why don't you just use like Amazon's ECS container service? And it's a great question. One of the reasons we didn't invest heavily in that, and not that we don't use it, because there are some deployments of it, but our overall goal when we looked at this as an enterprise capability was to have parity between the clouds and really embrace a hybrid multi-cloud model that we could deliver consistently from and not have to rejig and change around our delivery pipelines to integrate with these. So we embraced Docker Data Center, or now Docker Enterprise Edition, early on to help solve for that. So whether we're running in AWS or in our on-premise data centers, we're able to offer the same experience consistently back to our development teams.
So, as I mentioned, we were using Interlock 1.0, the open source product out there. And I'm sure many of you have tried a 1.0 release. It was definitely a 1.0 release. We had many issues with that. It was no longer quite being supported like it should have been. So we were really having a lot of pain. We probably were going down every day or two. The good thing is not too many people were using the environment at the time. We had the microservice team out there trying things out. They enjoyed the fact that they could kind of set up their own network behind the scenes. Our goal application was still trying to figure things out. They were very much an old-fashioned development organization. They had never played with tuning their own JVM. They'd never played with actually doing their own deployments, so they were learning a bunch of things. And then I mentioned that hardware resource out there. Well, the good thing is the vendor actually had a container image we could use for that, which was great. The problem was we had no automation to actually configure that, so people actually had to spin up that container image, go into the user interface and change the settings and save the image, and then push that out to our registry. So it was kind of fun, but it had a lot of problems. So we hit round 2, I will call it. We were looking around and, okay, Interlock is not for us, it's not working right, but hey, Docker is coming out with Docker Data Center 2.0, and it's going to have this thing called the HTTP router mesh. And that sounds like that might solve our Interlock issues and might get us more stability, and it's supported, which insurance company, we like support. So that's something we wanted. We also thought, okay, you've got the infrastructure that's backing up Docker Data Center, and then you actually have the Docker Data Center installation. So they really don't need to be in the same managed CFT. If you set up the hardware, why don't we have something separate? Other places in the company were using Chef to do that separation and do software configuration and management. So we figured, well, other people are using that. Why don't we jump onto the Chef bandwagon and we'll utilize that? There's a lot of experience. We can pull that in and start using that. And we need more Jenkins. We need more pipelines. We, in our non-production environment, don't have actual access to the AWS console. So if we need to do something, it needs to be through a pipeline. So there was more and more pipeline work that actually needed to happen, which meant pipelines from everything from deleting our CFTs if we pushed something out that was bad, managing EC2 resources that were bad, anything like that we needed to have more pipelines for. And unfortunately or fortunately, since we're IT and we're our own customers, we have to build it ourselves. We couldn't just go off to the Jenkins team and say, do this all for us. It's kind of up to us to build some of that framework because we kind of last on the list for support. The nice thing about this at this time is other groups were actually starting to leverage Jenkins for their builds. So the goal application was actually doing builds and going through Jenkins, doing some testing. They weren't quite into the whole CI/CD part yet, but they were getting there. But the microservices team was really pursuing this a lot. So when we hit DDC 2.0, we actually ended up looking at things and saying, okay, HTTP router mesh is actually a good solution. But we hit the one problem that we actually had from security, which was you got to have encryption everywhere. And the problem with the HTTP router mesh was if you go in there with encryption, it had to be done a certain way, which really didn't fit the framework we had set up. We provided to users an end URL that was essentially, when they created their application, they got a brand new URL, automatic, worked fine, certificates, all that stuff. So we needed something that worked with us. In order to solve that problem, what we ended up doing was creating the ALB on the front end that users came into with SSL, and then we re-encrypted the traffic and hit a front-end service that we actually created out there to do our decryption of SSL, do session stickiness, and then pass it off to the HTTP router mesh, which we could leverage as everybody else does. So we essentially put an Nginx proxy layer out there that was handling all of our traffic coming in. And this worked pretty well. It scaled. We were able to actually have multiple replicas of our service as well as the HTTP router mesh, and we were getting a pretty good amount of customers. So, things we found out with this. Jenkins was absolutely a godsend. The Jenkins team at this time took it upon themselves to essentially build some automation in, so a development team that had absolutely no idea about their JVMs or the application details of the application runtime could come in and say, okay, I have got a Node.js app that I just wrote because I wanted to learn Node.js. And they would say, okay, you click that button, it builds you a Node.js pipeline, and all you have to do is provide the app. And it went through and it built the application, managed the dependencies, put it into a container image, spun it up, and put it out into the environment so they could actually hit it, and they didn't have to worry a thing about it. But the pipeline guys were really smart in that they abstracted that out into an API. For those people, they could call the API themselves. For our more microservice people who were actually really adept and wanted to manage the compose file and how many replicas and whether you were doing a rolling update or a graceful restart, they gave them essentially a cleanse compose API that could go through and utilize the same process, but they would have all the control that they wanted to go through and do that. So everybody absolutely loved that. They also loved overlays, which is also a problem on the gotchas that I'll talk about in a second. Every application was out there. It's like, hey, I can put a web server and an app server, and all I have to do is call it app, and I just hit it, and DNS works, and it's great, and that's wonderful. Good stuff. They liked the environment. They liked what it was doing for them. And they were doing lots of builds and lots of usage. And we hit some growing pains. I mean, we scaled up from that initial number of servers from probably, I'm guessing, about 20 to, at this time, 60 or so. So we had a pretty good fair amount of usage. But we did hit some gotchas. Chef is great for configuration management. And you know what you don't really necessarily want to do with a Docker environment that you're updating regularly is configuration management. You want to rip those nodes down and put new ones in that have the latest patches and everything. So Chef, although it was great for some things, was not really what we should have used for that. CloudFormation dependencies. We hadn't jumped into Terraform yet. We still haven't, unfortunately. And you hit some CloudFormation dependencies. We had broken everything up into multiple CFTs, and that required us to essentially pass some stuff through, which caused dependencies. Our overlays actually brought us down. We had way too many overlay networks. In fact, we also had people who had taken, hey, here's an example of a compose file. And the example exposed, say, port 84 or whatever port they needed to. So they said, oh, I need to do that for mine. And so everybody was exposing ports. Well, at that time, I think we were about 1,000 services. So we had 1,000 services exposing 1,000 ports on there. And our nodes, when they restarted, they were going through IP tables and resetting stuff up, and it would take 10 minutes to go through and actually get apps up and running. And that was our own fault, and we had no idea what was going on. And this is where Docker was really helpful. They actually flew some guys out to work with us to help us figure out what was going on in the environment. And we had no clue. It's like, well, why are they exposing that? I don't know. And turns out we were able to eliminate all of that, cut down on some of the overlays, and really help with the scaling of our environment. We also have our own DTR. And we ran into some issues with that. As of November, starting in June till November of that year, we ended up with 1 terabyte of images, which is a good amount of images, which makes you kind of concerned about how I'm going to do disaster recovery with this, because there was no real good solution. And we hit some caveats with HRM, some of them possibly our own cause, some of them possibly Docker, but we ended up getting around some of those and being able to work through them. At the same time, we hit our goal application. It was kind of working off in the back end. The development team was working on the back end, trying to figure out how to actually do DevOps. Finally understanding that, hey, you're in charge of your database. That means you deploy your database out there. Absolutely talk to your DBAs. Talk about scaling. Talk about performance tuning, all of that. But it's your responsibility now to manage that. And you need to increase the size? You do it. You need to change your JVM parameters? You do it. That is your job. We can help you. We can assist you, but it's your job. So essentially, we went from a monolithic application with a few Java batch processes, that hardware image I talked about for the web user interface, and a back-end Oracle database. So we ended up pushing it out to the cloud. We ended up, I believe, with 10 separate containers doing Java batch, each kicked off separately. That web user interface is still there in that hardware container image running out there. They did not want to get off of that. Hopefully soon they will, because we don't like that particular image. And then we have a database in RDS that's actually replicated back on-prem. So we learned a heck of a lot, not only about containers, but getting to the cloud and AWS. It was a very trying period, but the nice thing is, it's been running out there since January. We've not had any outages. Everybody's liked the performance so far, and it's really given us an ability to say, hey, we've got this pretty significant application running out there in production, and we've done it all through Docker and AWS. So we started this in June of last year, and here it is, June of this year. Like I said, we hit DDC V1, DDC 2, used HRM. December we hit DDC 2.15 and we released our goal application. But right now in production, we've got 330 services in production that are using our production DDC cluster. I say DDC, I'm used to that, it's DEE, but hey, whatever. But the big story I find is our non-production. We have a lot of people using this. We've got 100 nodes in non-production right now. We've got 518 stacks. If you're familiar with the swarm nomenclature, essentially a stack is an application set, which could be a web server, application server, database, caching piece, whatever you want to put into your whole application suite. We've got 1,520 services. Services you can think of as essentially the same thing as you would in Kubernetes. It's a specific piece of an application, web server, application server. And we've got 1,977 running containers. I did this a couple weeks ago. I'm guessing it's probably gone up from there. But it's a pretty big environment. And we've grown it a lot, and we have a ton of usage. We're doing hundreds of deployments a day. People are building their application, deploying it out, building it, deploying it out, and it's running really, really well. So where are we going with our future on this? Well, we know that containers are essentially going to be an essential part of our business, no matter what. It's given us a ton of flexibility and a ton of agility that I don't see any other way we could have gotten. Virtual machines were great when they came out, but these are revolutionary, and we just see the potential with this. We're doing some crazy things with WebSphere Business Process Manager in containers. So we're trying to do anything we can to utilize this technology. We're looking at Kubernetes. Who can't be looking at Kubernetes now? I mean, a year ago, well, it was out there, but now it's everywhere. Kubernetes is something that you have to consider if you're looking towards portability in the future. So we're looking at it. More automation. We loved it when the DDC API actually came out so you can manage the cluster via API. We've got scripts now that you can actually do the day 2 configuration stuff via the API. That's great stuff. We want to do more. We need to do more. We don't want to have that be a manual process. Faster infrastructure upgrades. So our security team, encryption everywhere. We're in transit, in flight, at rest. They also said, you know what is also a great idea? Since you're automating all of this and you're able to roll out environments, what we'd like to see is you guys actually roll through your hardware every 14 days. So they essentially want us to roll through our infrastructure, our Docker Enterprise Edition engines every 14 days and rip down every single one of them, including the managers, and put them all back up. Inventory management is someplace we've kind of been lacking. We know we need to get more into that. A single pane of glass that will actually show people where their containers are, how many are running, what the state of them are, when they were last restarted, for every environment in one location. We're working on that. We've got a pseudo app out that we're testing, but we want to get better at it. We've got AquaSec in-house. We like it. It does our scanning. We want to use more of it. There's controls that you can put in so you can limit the number of executables that you can run in there. So you can just run Java if you're a Java application. No LS, no CD, no TCP dump. So we want to dig into that more. And we've looked at our environment and we've said, okay, how do we get these faster infrastructure upgrades? How do we actually enable testing of different types of technology behind this? So we're actually looking at, and in the process of, while we're out here enjoying ourselves, the guys back home are introducing what we're calling a smart tier between our ALB and our cluster. And essentially what that smart tier we're going to do is we're going to use Jenkins again, and anytime an application is deployed, we're going to have it update the routing configuration there. So we can actually take the applications and migrate them to new clusters with the deployment of the application. So if we need to do it, we just deploy the application. Could be an old image, doesn't matter. We deploy the application and it points to the new cluster. So we essentially can move people to new clusters without having to, one, bog them down about worrying how to do it, and two, we can actually scale test our new clusters. We can introduce 50 applications, 100 applications into that new cluster and make sure it's functioning as it should be. And if not, we can roll it back and they shouldn't notice anything. All the logs will still be going to Splunk. All the monitoring will still be going to Datadog. Everything should be the same. They'll just be switching between the clusters on the back end. Oh, and we'll be able to introduce Kubernetes as a service in there and migrate applications over there as well. All while having Jenkins do all the file creation, much like the Compose for the Kubernetes files. So we're really anxious about this. This looks like it's going to give us some functionality and features that allow us to kind of be more adaptive and more agile ourselves. So lessons learned. Do you want to start?
Yeah, I think this is a lot of stuff we can share here between what we've done over the last few years. And I think the biggest thing we found at Liberty Mutual was that the team alignment and working in an agile way is so critical to get this thing off the ground. If you don't start with getting your development teams, your operations teams, and your security teams rallied around this effort, getting people to buy into it both at the ground level and at the executive level, it's hard to be successful and move at any real pace with this. And what we've seen is really driving this through what we call is referred to as an inner source model within Liberty that's helped fuel this, where contributions can be generated from any of the market IT teams, central IT organizations, and contributed back to a common code base to continue to grow this ecosystem of technology that we provide around containerization. And I think it's really helped bring teams that were typically siloed in their direction and what their priorities were into common outcomes that we can help achieve much more quickly. So that's one of the ingredients I think that we found to get that right balance at Liberty Mutual to move forward successfully. And then can't say enough about the partnership from Docker. To be honest, like Michael said, not everything's been perfect. But again, we were very early adopters of this technology, so we didn't really expect that either. But what we can say is that working with them and having their support throughout this, and as Michael said, on multiple occasions, they've flown people in here to help us on weekends and make sure things get up, listen to us intimately about our needs to help evolve their product to meet us today and what we're planning to do in the future. So that's been a great partnership with them, working in an open way and in all honesty, a very refreshing one compared to maybe some of our traditional providers. Friendly testers, I think that's friendly testers and developers really is like getting started with this is finding the right group to really partner with. And when Michael talked about like the sales compensation application, right? That one was a good example of kind of getting the right people all in the same room talking about the goals that we had to be successful. And then even the people on the digitally native front that were building net new, greenfield, these really cool modern applications, getting them all ingrained around this so that you don't have these separate teams going off trying to solve or even complain, and getting them engaged so that they buy in and support this. So You want to talk a little bit about some of the I/O CPU challenges we've hit?
So one of the things through the whole journey that we've learned is I/O on hosts that are running containers is really important. That we found that out. We started out with what we thought were good sized EC2 images, and we learned I/O. We need to up the I/O. That was really important. CPU. We looked at our managers, and some of our issues, we hit race conditions in a couple places, but really they need the CPU in order to get the job done. So upping the CPU on the managers was really important. And funny enough, workload. If you're running a bunch of Java applications, you're going to get a lot less container density than if you're running Nginx. For example, we've had easily 100 containers running on a node with Nginx. Java, you get a 20 to 30 depending on what they're doing, and if anybody sends a performance test, you're going to have issues. Education too.
It's key. I mean, I think that's a tough one to solve for. I think one of the things we've seen at Liberty specifically is some of the Docker desktop tooling, the Docker Mac, Docker for Windows certainly helps in that regard. It's a really good local experience for developers to give them consistency. But I think even beyond that, it's that getting your teams to understand the value of containerization, kind of what we're doing, but also sharing more broadly. So we've done things at Liberty Mutual, like a in-house Docker Day event where we partnered with Docker to bring in some of their technology experts, bring in our technology experts, and lead sessions around, what we're doing here today, what we're planning to do in the future, talking about things deeply like Kubernetes and what our approach is to addressing that, and really doing this in an open manner so that everyone really understands. And again, it's not a siloed activity. It really has to be all of the organizations that are part of this and part of this whole transformation. And then I think technical debt. Who doesn't have it? I mean, if you're a unicorn out there and you get the luxury of just building net new greenfield stuff, that's awesome. I don't think for a lot of large enterprises that's the case. So it's something we had to take head on. And honestly, I think one of the applications we initially picked for that, it had a lot of technical debt. And I think it challenged us in a lot of ways around both cleaning up the tech debt in a way that worked with Docker and making security be first in terms of what we had to do. There was so much security around that application, we had to take it on up front and get our security teams on board and bought into this so that we no longer just bolt security on after the fact when we get audited or something. We actually shift it left in the whole development process and address it up front through software-defined controls.
One thing I would add about the tech debt, no matter what, when you're building your infrastructure, you're going to have decisions that you need to make as far as, okay, can I get this done or could I get that done? You're going to end up with tech debt. The question is making the right decision with tech debt. You have to understand that maybe 6 months from now, you're going to change your mind on a solution and it's going to be different. So, hey, tech debt on this instead of this. And sometimes you don't know, but accept the fact that you're going to have it and just try and keep it as minimal as possible if you can.
I think that's it.
That is it.
Thank you guys for hearing our story.